wysłuchanie. Mikrofony i wskaźnik czekają tutaj na krzesełku.
So good afternoon. My name is Adrianna Dudziak and this is Amelia Fabańska. And together with our colleagues from BTS Da Vinci Science Club, we studied the effect of the accuracy of the dart throwing on biomechanical parameters. So firstly, we want to tell you what is dart throwing. Okay, sorry. Dziękuję. Yeah, so firstly we want to tell you what is actually dart throwing. Sorry. Yeah, so dart throwing, if you think about it, it's a pub game. When you throw 3 darts on the dartboard, which is divided into sections from 1 to 20 with double and triple ring and, of course, bullseye. But dart is so much more than that. If you want to play and you ask yourself, like, what do I have to do? Most of you will say you need to practice, you need to throw at the board, but there's so much more to that. For example, in competitive setting, when you play game 501, you need to subtract the number you hit from the number until you hit 0. So you also need mathematical thinking, strategic thinking. So you see, dart is so much more than just throwing darts. But for us, from a biomedical perspective, the accuracy of the dart throwings depends mostly on the wrist and hand movements, on the footwork, and on the upper body kinematics. So to determine which position is the most accurate, results in most accurate throws, we use the BTS Smart System, which is a motion capture system, and also 15 markers that are placed on the body of our 2 competitive players. And 5 of them were placed on the hand, on the wrist, on the knuckles and elbows, and the rest of them were placed on the rest of the body symmetrically as shown on the picture. And every player throw 3 darts at the board to one of the 4 fields, which is bullseye, triple 19, triple 20, and double 20. And we also developed point-based system to see how accurate the throws were. So for example, you see for target triple 20, if you hit the target, you would get 3 points. If you were 1 section off, you would get 2 points. And farther away, 1 point. And if you were totally off the board or just far away, you would get 0 points.
For each throw, we calculated a set of following parameters: elbow angle, heel distance, shoulder displacement, the speed of the wrist and 2nd and 5th knuckles, and joint movement indexes. GM, or joint movement indexes, was calculated following this formula. X, Y, and Z are coordinates of a joint at a set point of time. H is player's height, and capital N is the number of frames or number of points in time. As I said previously, two of our parameters are vertical elbow angle and heel distance. Elbow angle, or vertical elbow angle, is not the angle between the arm and the forearm. Instead, it's a 2D angle between the vertical y-axis and the forearm. It demonstrates how far to the side the player moves their elbow during the throw compared to their wrist. Heel distance is the distance between the marker on the heel and the floor, normalized by player's height to make it possible to compare between players. Now we'll see our results. These are the graphs that show our 2 example parameters, elbow angle and heel distance for player 2, when throwing at target triple 19. In pink is the 3-point throw, meaning the most successful one. In blue is the 2-point throw, a little less successful. As you can see, player 2 was more accurate when his elbow angle was higher, meaning he moved his elbow a little more to the side, and when his heel was a little more lifted from the ground. Next is also the elbow angle, however, this time it's across all throws and with comparison between two players. For player 1, his more accurate 3-point throws
Yeah, so the more accurate 3 points were where the angle was greater, and you can see there is a difference between player 1 and 2 because they have a little bit different style of the game.
Player 1 moved his elbow compared to his less successful 0-point throws, less at the beginning of the throw, and his value of the elbow angle was also lower compared to 0-point throws later in the throw. Player 2 displayed a similar trend. However, in his instance, the difference in the slope between his successful and unsuccessful throws was less pronounced. This suggests that the to get more accurate throws, you need to get a higher elbow angle, but with less change during the whole throw. Now, heel position. These tables show the heel distance, but the mean of the whole heel position and the mean of the standard deviations during the whole throw. Here, our players show another difference between them. For player 1, his heel was a little lower to the ground compared to both player 2 and to his less successful throws. Player 2 was more successful when his heel was higher up from the ground, and as seen in the lower standard deviation for both 3-point and 0-point throws, we can deduce that players have a heel position that is most comfortable for them and a heel position that hinders their accuracy when they get 0 points. Shoulder movement is the movement of the shoulder, backward and forward movement during the whole throw. Both players displayed higher accuracy when they moved their shoulder further forward compared to 2- and 1-point throws. However, in both cases, 0-point throws had even higher shoulder movement. So this suggests that 0-point throws were more similar in body movement to 3-point throws, just more exaggerated, like the players were trying too hard to make successful dart throw. Also, the player 1 did a little backward movement before moving forward, which suggests that players had different throw styles. Now, to the speed of the second knuckle during the whole throw. Players were most accurate when the maximum speed was between 40% and 60% of throw time, and also when the throw time was a little earlier compared to less successful throws. Also, their maximum speed was higher in 3-point throws than in less successful throws.
Yeah, so in conclusion, if you ever want to play dart and need suggestions, first of all, the more forward shoulder movement that you have, the more accurate. You also need to lift your heel, and the more stable and consistent that lift is, the better. So if you think about it, those two things result in more forward position. So basically, the shortening the distance between you and the board, and that's why you are more accurate when you do it. Also, like my colleague says, of course, the more speed, the better the throw, and the maximum is reached between 40 and 60% of the throw time. But the more accurate is a little bit earlier, but don't try too hard, because then you will miss completely. And we also saw with our two players that had different styles. So maybe in the future, if we had more players, we could develop like the most accurate style, the style that is most consistent, and see what are the differences between different players across the board. So we want to also thank Marek Kubiak, which was help and put valuable information for us and help us connect it to other players. And we also want to thank you for the attention, and we hope now you improve your dart game. Thank you.
Thank you. Any questions from our commission committee?
First of all, great presentation. I'm a little of a dart player, so that hints on the end will be implemented in my game. And first of all, I want to ask about the influence of the warm-up of these players. So, where was does data taken from the start of the training session, or at the average, or at the end of the training session? So
no, first we tried to make the data as close to competitions. So first we let them warm up like they would before the competition, and then they would throw at the dart with a little bit of pause in between the series, like they would wait for another player to throw at the competition.
And also we repeated it like 11 times to, have the mean and standard deviation, so it won't be just like luck. Yeah, and also there were like between the throws, also in the competition there is a little bit of break. So sometimes they just throw 3 in a row, and sometimes they did a little break. But basically we just repeated it as many times we could, so we could get the more accurate data.
okay, thank you. And second question is connected with the release phase of the darts. So have you studied more about that, about the sleepiness of the fingers or something like that? Because it can depend on the game, and sometimes it's crucial. Not that phase with the movement, but the moment that fingers are putting away from dart and release it.
I mean, it's a little bit hard to determine, because with the markers, we had them on the body, not on the darts. So it would be difficult to pinpoint exactly where you throw the dart. We can see it, of course, with the movement, but maybe this is something to do with maybe next research, or to see it